today is to talk about the final exam time, okay? What date and what time of the day is the final exam? Okay, so that's the first thing we'll do. I might have done it before, I cannot remember. So we'll go ahead and make sure that we make it clear in today's lecture. Okay. All right. So when you go to the class website, you will find the final exam schedule, which is here. And I want to teach you guys how to read that table so that when you take other classes, if your professor doesn't tell you when the final exam is going to be, you know how to find out when the final exam is going to be. All right, so first of all, you have to go check the final exam schedule of the right semester because occasionally they might have another semester also up when you're planning for what classes you want to take in the following semester. So once you get there, there are a few options. Most people only need to look at the first two, where the Math Learning Center final does not apply, but unless you are participating in one class where you have to go to the Math Learning Center. So it's either daytime or evening. I think daytime it goes all the way to maybe 6 o'clock, and then evening starts at 6 o'clock. So this class is definitely a daytime class. So you go to daytime class exam schedule. And then instead of just jumping through this to look for the time when we start the class, we'll spend some time to look at the column headers. So regular class start time, day of the week, this is the final exam date and the final exam time. So the most confusing one is the first column, okay? Because it is not telling you if your regular class time starts within this range, then that particular row applies. Okay, it just says regular class start time. It's like, okay, what are we talking about here? Are we talking about 7 o'clock as a start time, or are we talking about 8:10 as a start time? That is giving you a range. Okay, so if the start time of a class is between, okay, in this case, 7 o'clock to 8:10 a.m., then this particular row applies. So for our class, our start time is 1:30. So we are going to scroll down a little bit. There we go. So this is a Tuesday, Thursday class. So you only have to look up the Tuesday, Thursday rows. And then the start time of this class is 1:30. So it is between 1:15 and 2:40 p.m. So this particular row applies to us. Our final exam date is 19th of December. And then the final exam time is from 12:45 to 2:45 p.m. in this room. Yes. So final exams, unless the professor says otherwise, is going to be in the same room, but the duration is different. So it's not a regular lecture duration. This is a 2-hour duration. And also because the start time is not 1:30, it is actually 45 minutes before our usual lecture start time. You might want to put it on your calendar because you have to be here 45 minutes earlier than the regular lecture. Okay, so if you're a creature of habit, or you have other things to do in the morning or something like that, make sure you put it on your calendar. So on that day, you know that you have to be here 45 minutes earlier than usual. Are we good so far? Because if people show up at 1:30, they would have lost 45 minutes of the exam time. And I cannot give those people back the time that they have lost. Because there are other classes scheduled right after our exam for this class. The same classroom will be used by other classes for exams. So you guys will have to arrive on time in order to have the full 2 hours to work on your exam. Are we good so far? Does everybody know what date and what time? You good? Okay. Question? Nope. Okay. All right. So that is taken care of. Are there any questions about the use of records? Okay, we spent a little bit of time to talk about records last time. So are there any questions about how we use records? How to make a variable that is a record? How do we access individual parts of a record? Yep.
So what happens when on like the line number when it says return like record or return value type and it says like boolean or whatever?
Mm-hmm.
Like, what do you do right there?
With
Like, if it said return type,
right, right.
what does that mean?
So, okay. So let me write an example to check whether that is what you're asking. Okay. Um, okay. We're gonna use mouse pad. Okay, mouse pad. Are you talking about something like this? You have a definition of a subroutine. Okay. So we'll just call it ABC, and we say return type colon integer, and then we say return just in a particular integer and define sub. So you're talking about something like this, and particularly line 2, what line 2 is doing. So what line 2 is doing is it is telling the rest of the program what kind of value can be expected from invoking this particular subroutine. So in this case, the invocation of this subroutine cannot be put into the condition of a conditional statement because it is not expected to return a true-false value. It is supposed to return a numerical value. On the other hand, you can use the return value for comparison. You can use the return value and put it into a integer variable. Okay? So does that answer the question? Okay, excellent. Any other questions? Yep.
Can you put multiple types into one statement? Like for example, you have type integer. Can you have like type integer and string?
So you mean the same subroutine have returning different kind of types?
Yes.
Okay. So that is a little tricky. It's a very tricky question to answer because it depends on the programming language. Okay. So let me give you an example. Okay, so we'll just go ahead and use ABC, okay, and we'll give it a parameter. So we'll say by val x, which is an integer. Okay, so it has one parameter passed by value, and x is expected to be an integer. And we'll get rid of the return type here. And then we'll say, depending on what x is, we can choose to decide different things. So we say if x is less than 0, then return true. Don't ask me why, it's just, that's what we want to return. And then else we return, I don't know, let's say 0 and if. So if we have a function like this, then it has two different types of values they can return. Depending on the value of x, which is a parameter, sometimes it returns true, and other times it can return a numerical value. In C and C++, this is not possible. A particular function or subroutine can only return one particular type. So it can say return type is an integer, then whatever you return has to be of the integer type. You cannot kind of have more than one types of values they can return. But when you're talking about other programming languages, like most scripting languages, like JavaScript, Python, and so on and so forth, then it is okay. You can actually you don't even have to specify, you do not specify at all what kind of value can be returned by a subroutine in those languages. So that's why the answer to your question is a little bit complicated. In the context of what most of you are going to take, which is cisp300, the answer is no. One function or one subroutine can only have one return type. Is that okay? All right. Any other questions? Any questions about the use of records? No? Okay. So just so that we know, okay, how we can use records, let's go ahead and use an example, okay? And we can trace this one, if we need to. So we'll define the record, okay? So record, I don't know, we can give it some random names, but I want to think of something that kind of makes sense. We'll make a color, okay? So we have a color type, which is defined by RGB, okay? So how much red do we have? It is an integer that goes usually from 0 to 255, because 255 is the maximum value you can store in a byte. RG, so that's green, and B is blue, okay? So very typically, this is how we represent a color on a computer, okay? Which is in terms of red, green, and blue components. If you look very closely to any type of monitor, if you use a loop or a magnifying glass to look at a monitor, you will see that every pixel, okay, a pixel is actually an abbreviation of picture element. Okay, so if you look at every pixel on the screen, it has three colors. It has red, green, and blue. Okay, if you, well, this one you cannot see because it's kind of fuzzy. It depends on how well the projector can focus. But if you go home and you have one of those LCD monitors, and you take a strong magnifying glass, you can actually see those three colors. So most of the colors that we can actually perceive can be a mixture of red, green, and blue. So that's why in computer science, it's very often that a color is represented by the components, the relative strengths of RB, red, green, and blue. Okay, so I'm going to give you a subroutine. Okay, and we'll say this is color blue. Okay, get blue. Okay, and define sub. And all this is going to do is you give me a structure. Okay, you give me a record of the color type. So we say by passing by reference, C, which is of a color type, uppercase color. And all I'm going to return, okay, so let me specify the return type as well. Return type is an integer. And all this is going to return is the blue component of a color. So all I'm going to do is to return the blue member of the structure or the record that C is representing. So let's check out this subroutine first, and let's see if we understand every single line so that we can kind of move on to the next one. So line 7 to line 7 and line 11, no questions about that. That's just defining the beginning and the end of the subroutine. Line 8 is telling us that we have one single argument or one single parameter, and the parameter itself is called C, but we also have a type restriction. You cannot pass an integer into this particular subroutine. You have to give it a record, okay, and it has to be a color record. The return type is an integer. In other words, where can I put an invocation of this particular subroutine? Any place that an integer can be expected. Do you mean you can put the invocation of this subroutine inside the square bracket when we access an array? Yeah, that's perfectly okay. Because inside the square bracket, when we access an element out of an array, the only requirement is one, it has to be an integer, and the second one is it has to be within a valid range so that you're not accessing an element out of range in the array. So that's what line 9 is saying, is where can I put an invocation of this particular subroutine? And this is telling you that anywhere an integer is expected, I can use an invocation of this subroutine. Line 10 is the only thing it's doing, okay? And it doesn't seem to be doing anything that's really fancy. All it does is it will take the blue member of the record that C is referring to, and that's the only thing it's returning. Doesn't seem like a big deal, right? Okay, so I can now define 3 other subroutines to deal with the green and also the red component. I mean, we got blue, so we'll have red and green. I'm not going to trace this program because I think, I might trace it just for a little bit, but the main point of this one is not for tracing, but to point out something that is actually more important than just tracing it. Okay, so now we have 3 subroutines, and they don't seem to do much, right? I mean, all they do is to return the red member, the blue member, and also the green member of a color record that you pass to the subroutine. Yes?
Okay, on line 8,
On-
when C is color,
Uh-huh.
then after that we keep using C instead of color. So what if we use color dot blue?
You cannot use color.blue. Okay, so that's a very good question. Okay, I'm glad that you're asking it. Okay. So the question is on line, what is color? What is color with an uppercase C? What is it identifying? It's a name, right? But what is it identifying? Remember the analogy of cookies. I didn't have lunch, so that's all I can think of right now. So remember the example of cookies, right? We got cookies, we got cookie dough, and we got cookie cutters. Okay? What do you think is color of line 1 trying to identify? No. Cookie dough are the columns. Okay? We can shape the cookie dough to do anything we want. Yeah? The cookie cutter, exactly. So uppercase C color from line 1 to line 5 is defining a cookie cutter. It's basically saying if you use this cookie cutter to cut out a cookie from cookie dough, each cookie cut out this way has 3 components. It has a red component, it has a component, it has a blue component. And each component itself is an integer. That is what line 1 to line 5 is trying to define, is a cookie cutter. So now we move on to line 8, okay, which is what you asked. So line 8, what is line 8 saying? Line 8 is saying, in order to run this particular subroutine, color get blue, okay, you have to supply a reference. So because it's passed by reference. So now the question is, a reference to what? And the type, colon color says, C has to be a reference to a color. In other words, C has to be a reference to 3 columns, and the 3 columns are basically quote unquote cut out using the cookie cutter that we call color. So are we good so far? Are we differentiating what C as a parameter is doing and what color is doing as a type restriction of what C can refer to? Are we good so far or not?
Why?
Why?
Because we reassign the color to the C, to use C after that.
C is a reference to a color,
But
to
why
something that
you
is of the
use
type color.
straight?
Huh?
Why you didn't use color?
Why don't we use color?
Yeah, color.
Because color is a cookie cutter.
It's like a box.
It is a,
Something that-
no, it's a template. It is a cookie cutter. It is a template. It is what you use to make something. It's like a stencil, okay? If you're painting, okay, do you guys know what is a stencil for painting purposes? Okay, so the stencil is color. Color is a stencil, okay? So you use a, hmm? Say that again?
The thing you put in the stencil is color, not the stencil itself.
The stencil, makes the form, makes the shape, right, of what you're painting.
I'm kidding.
Yeah, I know. But by itself, the stencil is not something that appears on a wall.
Yeah, I know what you're talking about.
Yeah, but I'm trying to explain it here. So if you want to use the paint analogy, the spray paint, the can of spray paint, are the columns that we have in the spreadsheet. That is memory. The stencil is color. Okay, it gives you a template. Okay, every time you want to draw this particular shape, use this stencil. Okay, but in order to actually have some painting on the wall, okay, you have to use the stencil and then you paint over it. That becomes the actual variable. The variable has the shape because of the stencil, but it has paint because it is made out of paint. It is made out of computer memory, which we use columns to represent in our class. Are we good? Yep, go ahead.
Can we refer by
Hmm?
value?
You can pass a structure by value, but it is usually not done that way. Because if you pass a structure by value, what happens is everything from what you use to specify the parameter is copied to the parameter. So it's kind of more memory intensive for one thing. It uses up more columns when we trace it. And 2, it doesn't really buy you anything. Okay? The only thing it's going to buy you is if the subroutine is changing the parameter, it doesn't change whatever you used earlier to pass as the argument. So passing by value is not usually done when we talk about records, which you will know as either structures or objects in C++. It can be done, it's just usually not done that way. So those are good questions. Any other questions? Yep.
Just to clarify, so it's referencing all three columns, right?
Okay, so it's a good question, and that's why I have to clarify. So C as a parameter is technically referring to three columns, okay? And it is also referring to how we should interpret those three columns. Because the three columns are really just three columns. They can contain three numbers, okay? But how do we interpret those three numbers? That's a whole different question. Are we talking about X, Y, Z as a coordinate in 3D space? Or are we talking about RGB, which is a color? So we don't know. But since we restrict that C can only be referring to a color, that means the first column that it refers to is the red member. The second column that that it refers to is the blue, and then the last column is the green member of a color thing. So is that answering the question? It's a little bit tricky to answer that question because in C and C++, it only knows where to find the first thing, but it also knows how big of a thing it's expecting. So it's a little bit different in terms of how we represent it compared to how we represent it in this class. So it appears that it would be helpful to run an example through this. Okay, so we're going to do it at some point. Okay, but right now, the question is, why do we want to have these kind of stupid, subroutines? Okay, because it would appear. Okay, let me make a main first. Okay, so we have a define sub main, and then as a local variable, we have C1 as a color. Okay. And we can initialize C1, okay? But the way we do initialization, I'm just going to do it with one of these, and then we can somebody can work on we can work on the other ones later on. So we say color set, okay? This is the name of the subroutine, and define sub, and I'll even use color set RGB, okay, as a part of the name. It's going to have 4 parameters. It will have one pass by reference parameter, which is the color that we are trying to initialize. It will have 3 by value parameters, which is R, G, and B as integers. And then the subroutine doesn't do a whole lot of apparently useful stuff. All it's going to say is the red component or the red member of C is getting the value of R. The green component of the color referred to by C is going to get G, and then the blue component, blue component of C is going to get B, okay? So that doesn't seem like very useful, right? I mean, it's a subroutine, it saves a few lines of code, but otherwise it doesn't seem to be very useful. So we go back to main, and then we say, okay, we want to initialize this C1 because as a local variable, C1 comes uninitialized. So we want to initialize it. So now we say invoke color set RGB, and now we have to pass the parameters. So I'm going to use C1 to specify parameter C, and then we'll now specify the values. So depends on what you guys want to do. Let's try to specify the color yellow. Okay, yellow is R, red and green being 100%, and then blue is missing entirely. That's how you mix the colors to get the color yellow. So we'll go ahead and set the color. Okay, so we'll say, let's do 255 to the red component, and we'll have RG. Okay, so next one is the green component, and then the next one is the blue component. So this is how you make C1 as a local variable of main to represent the yellow color. Are we doing kind of okay at this point, or we are getting lost? Go ahead.
Why the blue is 0?
Hmm?
The rest is like.
Because we're trying to mix the color yellow. So if you want to have a kind of like a quick way to reference, what each color is made out of in terms of RGB, you can probably just look up, color table RGB, and there we have it. We just look at one of these, and there we go. Okay, so let me get it a little closer. So this is how we code color in HTML and many other ways. When you look at these are hexadecimal numbers. Yeah, it's going to be another day to talk about these. But the first one is R, the second one is G, and then the last one is B. That's how we represent RGB. So when you look up yellow, which is right here, RG are both FF, which is as large as they can get, and then the B component is a 0. So that's how we mix red, green, and blue to get the color yellow. Is that okay? Kind of quick way to talk about how we mix colors in a class like this.
Is it
Yep.
recording?
I believe so. Yep, it is recorded. It's recording because I can see the green light in OBS. Okay, let me move this around a little bit so you can see it. So we are actually recording. Okay, very good. Okay, so let's go back to our example. Okay, so I seem to be doing a whole lot of stuff that really does not need to be done, right? Because instead of using the subroutine called color set RGB, I could have done it this way. I could have said the red component is getting 255, the green component is getting 255, and then the blue component is getting 0. So I could have used lines 36 to line 38 instead of line 35 and get the same thing done. And I do not need the subroutine called color set RGB anymore. Does that make sense? Okay, does everybody understand the argument of, well, you don't really need the subroutine called color set RGB? Yes? Okay. So now the question is, why? Why do we do this? Why do we use a subroutine instead of just accessing members of a particular object that is of the color type? Okay, so I'm going to end the subroutine first, and just have the invoke main from the outside. So the question is why? Well, as it turns out, different colors, depending on what is the purpose, colors can be mixed using different methods. Okay, so RGB is one that is really well known because RGB is how we see colors from a screen. But what about prints? In other words, you open up a paper magazine, you look at something that is yellow in color, and then you use a magnifying glass, okay, and you say, okay, how is that color mixed? What do you think you will find? If anyone has worked in an actual print shop, you would probably know that answer. If you have replaced ink cartridges on a color printer, you might know that answer as well. So how many people have changed either the cartridge or the ink on a color printer before? Okay. Does it use one single cartridge, like it has all the colors in it, or does it have one color per tank?
Some of them it has a CMYK.
CMYK, exactly. What is CMYK? What does that represent? So CMYK stands for cyan, that's the C. M is magenta, Y is yellow, and then K is black. Okay. So as it turns out, because when you display something on the screen, it is called an additive process to mix colors. But when you're printing, it is a deletive process of removing colors. So it's a filtering process. It's a filtering mechanism. So when you use CMYK, that means we are mixing all the colors that we can see from these primitive colors: cyan, magenta, yellow, and black. So depending on, so this representation of color, let me go back to the beginning, okay? So the way we define color as a type, the way it is right now, makes perfect sense when you're dealing with images, like PNG files, GIF files, JPEG files, or anything that you project onto a projector. This makes perfect sense. But it doesn't make sense when you are dealing with printing on a piece of paper. because in that case, we want to represent colors in CMYK. Are we getting that idea of there are different ways of representing colors? Okay. There's also another way called, I think it's intensity, hue, and saturation. Okay, if you play with the GIMP or Photoshop, you would see all of these different ways of specifying a color or changing a color. Okay, so there are many ways to specify a color. Which one makes more sense depends on your application. If you're dealing with a projector, RGB makes more sense. If you're dealing with a printer, CMYK makes more sense. If you're dealing with a photograph processing thing or in the camera, maybe intensity, hue, and saturation makes more sense. Okay, so it all depends on what you're doing with the device. Are we doing okay so far? Okay, so let's just say the rest of the program does not really care how a color is represented. It's just a huge two-dimensional matrix of colors. Okay, and then one day your boss comes to you and say, that program that you have that can plot complex shapes is really good. I like to use it, but instead of projecting the image onto a screen using RGB, I want to change that program so it prints the pattern on a piece of paper. Okay, and then your boss says, well, but in that case, we don't want the underlying representation to be using red, green, and blue. We want it to be in CYMK. Okay, so we'll go ahead and change it to CMYK. Okay. So here's my change. C is cyan, M is magenta, Y is yellow, and then we have one extra one, which is black. Okay, so now I have changed the underlying representation of a color. But remember, the rest of the program only knows about color being just color. How it is represented underneath should not be important. Is that okay? So if you do not have any code that looks like this, okay, if this code does not exist, okay, so let's get rid of this. Then what else do you need to change so that the program continues to work? You only have function calls to color set RGB, color get green, color get blue, color get red. You only have to change those subroutines. Whoever is invoking those subroutines do not need to be changed. Is that clicking? In other words, you want to minimize which subroutine actually needs to know the actual members of a particular type. You want to minimize that so that the rest of the program only needs to invoke the subroutines in order to access or change certain aspects of a color in this case. Let me present this in a slightly different way, in a different analogy. Okay? Before the time of most of you, okay, not all, but before the time of most of you, televisions used to be a gigantic thing, with a big, huge, gigantic vacuum tube as the main device. Okay? Is that clicking or not? Sort of? Okay, I'll give you a picture just so that we have a visual. So let's look at a CRT type, color TV. Okay. Cathode ray tube. Yep, that's the actual name. And I do not know they can still buy those things. I'm really surprised. Okay. So these things operate entirely differently compared to your flat screen LCD television. Okay, there's an electron ray gun, okay, so to speak, that generates electrons, get them accelerated, and then there's another deflection mechanism. Okay, just kind of imagine it this way: you have a continuous source of electrons being shot out of this mechanism. Let's call it an electron gun, and it's continuous. So you have a stream of electrons coming out of it. So what you see on the screen, if you don't do a single thing, you see a really bright dot at the center of the screen, which is not very helpful. Okay? So what you need to do is to say, electron beam, I want you to start over here, sweep, go back to the next line, sweep, go back to the beginning of the next line, sweep, and so on. So you want a sweeping pattern. And that is done by magnetic fields, which can, no, I take it back. It is done by charge. Or was it magnetic? Huh? Electrical field? Okay. So you can use electrical field to deflect, where the electron beam is going. So now you can do a sweeping pattern. Okay. You want to increase the intensity, you make the electrons go faster. If you want to decrease the intensity, you make the electrons go slower. So if you want to control the picture quality of a television like this, you really have all of those things to control. Okay, how big is your picture? Okay, because you want to change the deflection thing to make it fill up the entire screen. Is that okay? And then your LCD TV has an entirely different mechanism. Okay, it uses individual pixels, and then on the individual pixels there's a polarizer, and then there's a liquid crystal component, and therefore the name LCD. Okay, and then with a liquid crystal, depending on the charge that you present to that particular layer, it can align in different directions. So it can basically block the light, because if one layer is polarized this way and the constant layer is polarized this way, then you have no light passing through. If they're both aligned the same way, then you have the maximum amount of light that can pass through, which is not really a whole lot. Okay? But the way you control the intensity or the brightness is entirely different. Is that okay? So now the question is this, okay? Let's just say that your parents are just, upgrading from a traditional CRT TV to an LCD TV. Do they have to learn the physics behind the display? Do they have to take another class in physics just to know, oh, so this is how LCD TVs work, and now I can now control the picture quality of a LCD TV. Do they have to do that? No. Why not?
Because there are smart people thinking about this
Uh-huh.
in their heads.
So from your parents' perspective, okay, even though the TV has changed, right? The weight of the TV has changed, the way you put the TV has changed. What has not changed? The remote control, very good. Okay, so the remote control has not changed, okay, because it still has the same brightness control, it still has the same channel change thing, so the remote control has not changed. So what does that have anything to do with what I just presented in the code? We can change the underlying mechanism without changing the user interface or what is presented to most people. Is that okay? Yes? So, okay, let's go back to the code. Okay, let's go back to the code, and I'll use this analogy a little bit more. Okay. So I'll present the code earlier. So we have red. So this time we have our CMYK. So cyan is going to be 0. M is magenta. Magenta is also 0, but yellow is by itself, so we can specify like maximum for yellow. And then black is also going to be 0 in this case. So using it this particular way is to say, I'll just rely on the remote control. Okay, the subroutine, okay, color set RGB will be able to translate the color specified in R, G, and B, and it will know the logic to convert it into CYMK. I don't need to know that. Is that okay? The separate way, the second way, which is specifying the individual colors or specifying the individual color components, is kind of like oh, now I have to understand the mechanism of a particular television. I have to understand what is a CRT, and then now I have to understand what is a LCD, because I'm looking into the actual low-level detail of the thing that I need to work with. Are we kind of getting the general sense of the idea? Okay. So what this means, okay, as far as programming is concerned, is lines 37 to line 40 is not what we want to do. Okay, we only want a very limited number of subroutines, like color get red, color get green, color set RGB, and so on, to really have access to the individual members of a certain record type. Once we have that set of subroutines, with the rest of the program will only make use of the subroutines, and nobody else should access the individual members anymore. Are we still doing okay so far, comparing the two approaches? No? Okay. I'll try to think of another way. Circular coordinate versus XY coordinate. Okay? So I'm going to use it as an example. Okay. So this is my reference point. Okay? We call this the 0 point. Okay? This is the origin of everything. Is that okay? So the usual way of representing a point, okay, I'm going to use a different color here. So let's say we want to represent this point over here. So the typical way of doing this is we use an XY coordinate, right? So we move over this many pixels, and then we move over this many pixels. This is the Y, this is the X, this is the X, this is the Y value, right? Okay. So this is typically known as the XY coordinate. This is great for display purposes because when you look into a screen, it is really just a whole bunch of little squares, and they're arranged in XY method. So this method of encoding the position of a dot works out great in most applications. Okay, it works out with a printer, it works out with a screen. It doesn't work out on a bicycle wheel. And then you go like, what does a bicycle wheel have to do with this? Has anyone seen it's called a percentage effect, where you can mount a bar of LEDs on a bicycle spoke, and as the bicycle wheel turns really fast, it can display images. Has anyone seen that? No? Yes? Who has not seen that? Okay, so I'll give you some examples. It's really cool. Okay, so we'll go to bicycle wheel, LED, light, image, and whatnot. Okay, so we'll pick up something that's kind of fancy, like this one. This one looks pretty fancy. And we'll go this mode. And it doesn't have, okay, it's not dynamic, so we'll look for something that is dynamic. Okay, there we go. Do you see? Okay, right there. Okay, do you see what I'm talking about? So it's not one single bar in this case. There are 4 LED bars that are mounted to a bicycle wheel. As the bicycle wheel turns really fast, by controlling each LED on each bar individually, based on the position of the bar at the time, you can use that to display images. It's a great idea if you live in Davis. If you're a student at Davis, you ride your bike all the time, you can now charge people to advertise with your bicycle, right? So here's your $1 million idea. Okay, as a student, you make a startup company, and then you sell these things, and you get to advertisers, and then you get to students, and then you just take a cut of the thing, of the stuff. You ask the advertisers and say, give me $20,000. We'll get your product to be visible to all the students, and then you pay the students like $11 an hour, or measured by miles or whatever, right? And then you pocket your money in between. Okay, sounds like a great business plan. Okay, but anyway, I'm too old to. I don't have the energy to try it. You guys have the energy. So, but the idea is you have to encode each pixel, okay, each picture element based on an angle and how far it is away from the center of rotation. That make sense? Okay. So that means in this particular picture, in order to define the location of this dot here, I am no longer using the xy coordinate. I am now using the radius and also the angle to encode that location. Does that make sense to you? Okay. So that means, as far as our program is concerned, now this is, this works in pseudocode. It also works in actual code. So I'm going to define coordinate as a record. Okay, and record. So when you first start on a particular program, you might say, oh, for now, I just have, I just need to work with XY coordinate. Okay, so the underlying representation is really just the X and the Y components. But you, instead of accessing X and Y as members, wherever you go, you use subroutines to do it. Okay, so you define coordinate get X. Okay, and you pass by reference the a coordinate. Okay, so you say C is a coordinate, and all it is going to return, we have to specify the return type too. Return type is an integer, and all you're going to return is really just the X member of that thing. And define sub. Okay, and you need another one for Y. Okay, which is going to be pretty much the same thing, except the name of the subroutine and also which member you're returning are different. Is that okay? And you're going to have another subroutine, coordinate set based on xy, and then you say by reference C, which is a coordinate, and by value x and y, which are integers. So with this, you just say the x component gets parameter x, the y component gets parameter y, and define sub. Okay? So once you have these three subroutines done, okay, the importance of the three subroutines is there are two to get to individual, coordinate members, and then the third one is used to change or to initialize it. Okay, so with all of these three done, then in your main program, then you can now have a local variable. Let's say it is C1, which is a color. Okay, so you can now say I want to set the coordinate. Okay, so you invoke coordinate set xy, and then you say the one I'm trying to set is local variable C1, and I want it to be at location 5 as far as x is concerned, and 16 as far as y is concerned. Okay, so this is how you set the coordinate, set the location of one coordinate. So you can use a loop. You can use this particular function call to plot a line, a circle, any kind of shape. Okay, if you have a two-dimensional image, okay, you can now use this to display something on the screen. Are we doing okay so far? So in a typical program, you will end up with a lot of invocations like this. Okay, so you have a lot of invocations of coordinate set xy, a lot of get x and get y throughout your program. Are we good so far? So let's just say that you have 2,000 of these calls within the program. Okay, in order to paint pictures on the in this case it would be a regular xy coordinate thing. Then your boss comes to you and say, well, that LED, static LED display is great, but we want to market something different now. Okay, we want to market that spoke on bicycle wheel display thing. And now you go like, oh, if I were to do that, the native representation of the coordinate really should not be xy anymore. So you have to change your program so that it becomes a r and a theta. It becomes the radius, okay, of the rotation, and the theta, which is an angle. Are we doing okay so far? So what else do you have to change in your program? you have thousands of calls to the subroutines, but other than the subroutines, nobody else is using the member X nor the member Y directly. So that means none of those function calls need to be changed. You only have to change these three subroutines, and you're all set. Are we understanding the benefit of programming in this particular way? To try to restrict who can read the actual members of a record, and then the rest of the program would use subroutines to access those members. Is that okay? All right. Now, I do not like to leave things hanging. So in this case, r is going to be an integer, but theta probably needs to be a real number, because even though we can represent an angle using an integer, it's probably better in this class to use a real number. So how do we do that? X is no longer a member at this time, but we do have the theta, which is the angle, and also the radius. So how do we get to the x coordinate based on the angle, the rotation, and also the radius? Hmm? It's r times what? Let's assume we have trig functions.
It's like
Sine and cosine?
It's which one? You got a good guess. Cosine, that's right. Okay, so we have cosine of theta. And then the other one is going to be r times the sine of theta. Okay? And same thing over here. Okay? If you give me the xy, I can come up with the angles. Okay? So the r and the theta, how would you compute those? R is easy. The square root of x squared plus y squared, right? Because that's just the, well, okay, it's not quite that simple because x and y can go negative. So you might need to do an absolute function first before you, okay.
Nah, because square would make it.
Oh, right, because squaring will make it positive again. Thank you. Okay, I have to take my math classes again. What about theta? Arc
Arctangent of y over x.
is arc tangent, yep, of x divided by y. Now there is a problem, okay? Because
Y divided by x.
because y can be 0.
Y divided.
Y divided by x. Yep. Okay. But there's still the same problem because x can be 0.
So that's gonna be error.
So you need a conditional statement. You need a conditional statement so that when x is 0, you have to treat it differently. Now there's one really kind of odd problem in this case is what if x and y are both zeros? Then you're really talking about this origin itself. The angle does not matter anymore because your radius is 0.
just a dot.
Yeah, just that dot at the spoke, at the axle of the wheel, which is not a problem because those display cannot display something over the center of rotation. Okay, but this is it. Okay, all those other thousands of calls or subroutine calls to coord get y, coord get x, and coord set xy, none of those need to be changed. Are we understanding the importance of this kind of programming?
So you only change the subroutine itself.
Yep. You only got a few subroutines to change because only those subroutines are sensitive to how the record is actually defined.
Like the masterpiece, like, and everything else is calling on them to say, hey, what should I do? And they are saying like, this is what you should do.
Exactly. So the subroutine is not only specifying how something is done, which is independent to how something is represented. And you have that, you now have the separation between those two. So let's just say the next form of technology for television is laser-based. Okay, so you have 3 lasers, inside the projector, and then there's a scanning motion, with a mirror, and then it's just the RGB, lasers, shining on the screen. Okay, so in that case, you have to relearn the physics of how to control the intensity of a laser. Nope, you still have the same remote control, right? And the remote control is corresponding to the subroutines. The actual mechanism behind a display technology is how we define the record type. Now, this method is called encapsulation. So the full name of this particular principle of programming is called encapsulation, which is basically hiding details. Okay, and any program written in this way there's a name for this type of programming. It's called ADT. It's not a security company. It's abstract data type. Okay, so if you look up abstract data type, they would point to concepts like this. Then you ask, well, who invented abstract data type? Why is it important? I think it's a concept back in the 80s maybe. Okay, so you will say, oh, that's useless. Okay, this is today. Okay, we are 40, 30 something years from when abstract data type came along. But can anyone guess what abstract data type became later on in the late 80s? You guys can guess. Throw all the technical terms you know about programming languages. How about object-oriented programming? Has anyone heard of that term? Okay. Object-oriented programming stems from abstract data type. So when you're moving on to cisp300, 400, and 430, they are really just more advanced versions of what we have just talked about. But the same idea carries through in those classes. Is that okay so far? I may be kind of like throwing stuff a little bit too far, but does everybody understand why we want to program in this particular way? Yes.
Can we like theta minus theta is like negative? We can use over here.
Can we say that one more time?
Backward. Over there we go to like clockwise. Yeah, have to. I guess like the clockwise it should be like this backward. The angle should be negative, so
The angle is usually measured in this direction.
it should be in the backwards.
It should be in this direction.
Yep. It's possible.
It's just a mirror image, right?
I guess
So,
like
so,
a picture,
huh?
a color. You can make a picture on the wheel. If this one is like backward.
Yeah, it's just a direction of the rotation.
I'll do this.
Okay. Okay. But this is important because if you have a picture, okay, so let's say you have this, kind of weird shaped picture here. So what your program needs to do is to say this is the center of rotation, and there will be sensors to tell you where each LED bar is located at that time. So these are the 4 LED bars, okay? So with those 4 LED bars, okay, using a program, okay, you can now figure out, what pixels should be in what color at that moment. So by scanning the 4 LED bars really fast, like on a bicycle wheel, and using the persistence aspect of human vision, now you can actually see images, when somebody's riding a bike and passing by. Is that okay? Does that make sense? It's just an example to illustrate why this style of programming is useful. Any questions? What about a 3D thing? Yep. So what you do with a 3D thing is you need to have LEDs, in different center points. So now you can spin the entire thing as a sphere, and then you can potentially generate holograms, using that particular way. So that would be kind of cool. The other way to do a 3D thing is to have a drum. Okay, so we'll give you a side view of this thing. So you still have 4 bars, okay? Except the bars are not two-dimensional. So each item of the bar actually has volumes. So now you have sticks coming out of each bar, okay, like that. So when this thing spins, okay, in this in whichever direction, so now you have a drum, of the LEDs, right? It's kind of the fancier version of this. Just imagine this has multiple layers, sticking out this way. So now you can have a drum, and any object that fits within the drum can now be displayed in 3D. So that's kind of one way to generate a hologram. Of course, the difficulty is when this thing spins really fast, these vertical sticks, they all want to fall because of centrifugal force. So you kind of have to you probably need a acrylic plastic thing to encase everything. So this way, you have just, acrylic plastic for the entire thing. But I'll let you guys figure out how to get it to work. So are we still doing okay so far, as far as records are concerned? Yep.
We're not going to have to do this in final edit.
No. No, but this can be very useful in your future classes because the concept, so this has nothing to do with the programming language. In C and C++, if you choose, you can choose to access the individual members of any records or structures all day long. It's just that your program would be very difficult to maintain. If somebody wants to change the definition of the record, you have a lot of work to do. Right. The concept is important, and I cannot really test you much on the concept, but I can test you on, okay, with something like this, when you trace this subroutine, what does it do? Do you know how to access a particular member? Oh, okay. Actually, this is wrong. Nobody pointed out that I made quite a few mistakes on line 9 and line 15. Okay, so I'm going to say that on line 5, there are a few mistakes, 2 to be exact. And then on line 15, we also have 2 mistakes. What are those mistakes? Let me just kind of put the cursor over here so we can kind of look at that line. Exactly. Whose R are we talking about and whose theta are we talking about? Because R is not a parameter. R is should not be a global variable. So if the compiler goes through this code, the compiler is going to be confused. It's like, what R are we talking about? What theta are we talking about? So how do we fix that problem? Hmm?
Local variable?
No, not local variable. Whose R and whose theta are we talking about? Parameters. Okay, very good. So there's only one parameter in this case, right? So how do we specify this is the R member of the parameter? What is the notation that we use in order to say?
Like integer or something?
No, C dot. Very good. So C dot R and C dot theta, because we are referring to member R and member theta of the structure that C is referring to. So I totally messed this up because I forgot to specify the C dot earlier. Is that okay? Are we good? All right. Does anyone want to trace through this code?
Yes.
Okay. All right. So, okay. So we'll just trace it as it is now. Okay. So we'll invoke main from here, and then new window. And I'm going to use the line number that is in the editor. So I'm not going to do it. There's no need to put it into a spreadsheet. Oh, I cannot use well, I can, but it's really cumbersome. I'm going to go get a spreadsheet here. All right, there we go. All right, so the first line that we start off with, line number, and then we have, there are no global variables. We do not have conditions, so we are good. We don't need a comments line here. So the first line that we start off with is line 30, because that's the only line that is outside of the definition of a subroutine. That's invoking main. We need a return line number to post. And then we also have a local variable in main, which is C1. But C1 is tricky because it is not an integer, it is a record type. So each member of the record type needs a column. So C1 has a R column. It also has a theta column. Are we good so far? Yes? And each one is a question mark because it is a local variable, so we really have no idea what values they start off with. And then we get into the subroutine, we get into main. Main doesn't do much. On line 27, we are invoking coord set xy. So that means we have another return line number. This time we return to line 38. And then we have 4 parameters this time. Actually 3 parameters. So we have C1 as a parameter, C as a parameter, X is a parameter, Y is a parameter. We utilize C1 to specify C, so what should I put here? It is passed by reference. AKA column C to D. Because a coordinate takes up 2 columns. So C1 really is kind of more like this. It is using both column C and column D. But if you want to refer to just column C, then you have to say member R of that record. If you just want to refer to column D, then you say member theta of that particular record. Okay? And the way I specify X and Y are 5 and 16. Okay, so we can put a 5 here and a 16 over here. All right. Are we doing okay so far? Okay. So now we get into the subroutine, get a coord set xy, and start on line 21. So line 21 first has to calculate x times x plus y times y. So what x are we talking about? Parameter x, which is here. Which y are we talking about? It's parameter y over here. So we have to compute the square root of that sum of squares and then put it into C.R. So that is the trick, okay? Assuming we have that number computed, where are we supposed to put it? We don't put it in column F because column F is a pass by reference parameter. So we have to look at what it is referring to. It is referring to column C and column D. Within column C and column D, we are now interpreting these 2 columns as a coord or coordinate. Of these 2, R is the one in the first column, which is column C. So that means on line 21, we're supposed to change column C instead of column F in the trace. Do we have any questions about that part? So we're good, okay? So the nice thing about using a spreadsheet is I can actually do the calculations. So I can actually calculate the square root of 5 times 5 plus 16 times 16. Okay, and that turns out to be 17. Exact. That's creepy.
16 is almost 17.
Huh?
It's too small.
Why is it too small? It's the square root of 5 times 5 plus 16 times 16. So that turns out to be one of those kind of weird numbers, right? Okay. I did not intend it as such. It just kind of turns out that way. All right. So on line 22, what do we do? On line 22, we compute theta, which is arctangent of y divided by x. So that has to go to column D. It does not go to column F because column F is just a reference to the columns that I'm supposed to be using. But of the 2 columns that C is referring to, line 22 says, I just want to change theta. So theta is column D within the record coordinate record that C is referring to. So we're changing column D. So we just say arctangent of y divided by x, and that's our number. This number, by the way, is in radians and not in degrees. How many people know what is a radian versus the other way of measuring angle? We good? Okay. So if you want to convert this into the number of degrees, what do?
Multiply by 180.
And then divide it by pi. Exactly. Yep. Okay, very good. But in this program, I never specified the unit of the angle of theta, so we are okay with using radians. Okay. All right. So now we move on to line 23. These two steps are the most important parts of this particular demonstration. Yeah, it's going to recover. Just give it a moment. But do we have any questions about those two lines? The execution of line 21 and line 22. We all good? Okay. So now we get to line 23, which is the end of coord set xy. So at that point, we have to look up the return line number, which is line 28. This tells us that we have to continue execution on line 28. And then every single column that we allocated for this invocation, they all need to be deallocated at this point. So that part has not changed. So the concept of records is not going to change whatever we have learned before this concept. It is really kind of orthogonal to all of the other concepts. On line 28, what do? It's the end defined sum of main, which means now we deallocate everything for the invocation of main, and also we have to retrieve the return line number first. So return line number is post. This is where we're going to go. And now we have to deallocate these three columns. Columns B, C, and D. So now we just mark it. And now we continue execution at post, which means we are all done. So do we have any questions about the trace of this particular program?
So
Yep.
our results are 17 and 1.268 for this program.
Mhm.
So what is the result?
The result is, well, this one has no color. This one has to do with coordinate. So the end result of this program is we ended up initializing C1 as a okay, fine. I still refer to color even though it is supposed to be a coordinate. Okay, there we go. There we go. So the end result of this program is we computed the coordinate of C1. Internally, it is represented as radius and theta, but what we supply to initialize it is in x and y. But if you have another way to represent a two-dimensional coordinate later on, we can change the record type, and then we have to change coord get x, coord get y, and coord set xy. And guess what? The main program doesn't need to be changed. That is the value, because we are isolating changes to the implementation of the record from the logic that needs to make use of that type.
It stay like formula.
Hmm?
Like a formula.
The formula would need to be changed. Okay, so if you go to, so I'll give you an example. So if you go here and you say, okay, I have another way to represent a point in two-dimensional space. The moment you change that, then you have to change this line, you have to change this line, and you also have to change these two lines. But the rest of the program, as many times as they use the subroutines, coord get x, coord get y, and coord set xy, none of those need to be changed. And the idea is there will be, I mean, this is not a realistic program, right? I mean, because all we did was to initialize a local variable, and then we got rid of it. So, but in a real program, you would have a lot of subroutine calls to coord set xy, coord get y, and coord get x. So none of those invocations will need to be changed. And that's the whole idea of ADT, or abstract data type programming, is you only confine yourself to a very small number of subroutines that need to know how a particular record is implemented. The rest of the program will only access a record indirectly using subroutines. So the subroutines becomes your remote control. It is independent of the actual technology behind the display. And you just have to say, well, I got your brightness control, I got contrast control, and I have an on-off switch. I'm good. And you don't need to look into how the color or how a picture is projected. Is that okay? So once again, the content of this particular lecture is not going to be very testable in this class, okay? Because I'm more focusing on the mechanism of how do you call something and pass parameters by reference or pass parameters by value. The idea of containing access to individual members only to a few subroutines is going to be something that you need to use and also make, and it will be important in other classes that you're going to take. So are we okay so far? More or less? Okay. On Thursday, we're going to take a review of the final exam. So the final exam is once again next Thursday from 12:45 to 2:45. On Thursday, we're going to look at the past final exam from last year so that you guys have some idea of what questions I asked a year ago when I taught this class. We good? Okay. So you might want to do some studying, okay? Because on Thursday is our last lecture. That's the last chance to ask questions in class. I do have office hours throughout the entire final week, so you can still come see me and ask questions at that time.